Here are the solutions that go with section 4.1, what we're calling assignment number 1. All right, these are some problems from a different book. I thought our book got into things and got a little too heavy, a little too fast for what I would like. So number 3 from this assignment here, we've got the expression x squared y cubed, and it says to differentiate the expression with respect to x. That means take the derivative of this, assuming that like x is like the right variable, which is what we're used to. So what's the derivative of this? Well, this is a product, and I'm going to go ahead and show you the make sure that we're familiar or getting familiar with this notation. What we're doing is we're taking the derivative of this. So notice that this does not have a dy. There's no y there. This is this dx. So this says, in very compact notation, the same thing that the directions say. This says take the derivative of this with respect to the variable x. Okay, so it's a product. So let's see. That means I need to do the product rule. The derivative of the first times the second plus the first times the derivative of the second. The derivative of the second is 3y squared, but any time that you take the derivative of something with a y in it, a dy dx is going to pop out. That's the new thing in this section 4.1. This is called implicit differentiation. So we found the derivative of this expression, but the derivative of this expression had a derivative in it. So, you know, it is what it is. Got to deal. And how we deal with that exactly will depend on what we're trying to do. But for now, that's it. You want to simplify this a little bit? I guess you could move the 3 to the front. There's not really a whole lot you can do. All right, number 5. We want to take the derivative of x squared plus y squared to the 3/2. Okay, the derivative of something to the 3/2, let's use the power rule, it's 3/2 times whatever the thing is to the 1/2. Right, exponent comes out, drop the exponent by 1, and then that's what the thing was. The thing does not change at this level, right? That we're doing the chain rule here. The derivative of whatever's behind my finger to the 3/2 is 3/2 times that same thing to the 1/2. And then we multiply by the derivative of what's inside. The derivative of what's inside is 2x plus 2y, but I just took the derivative of something with a y in it, so the dy dx pops out. Really great way, especially if you feel like you're stuck early on in an assignment. A really good way to use these videos is to work along with me, and as soon as you think you're getting the hang of it, you pause the video and try to do as much as you can, and then start the video up and then pause me again when you think you know what you're doing, and so on and so forth. Kind of like we're sitting there doing it together. All right, that's a z, and that's a 2. So how about what's the derivative with respect to x of z plus z squared? Well, let's see. Neither one of these is the right variable, so the derivative of z is, well, by the power rule, it's just like 1, right? But it's not the right variable, so a dz dx pops out, just like dy dx is popped out here, plus, what's the derivative of z squared? 2z, but z ain't an x, so that means a dz dx pops out. I'm totally fine with you leaving it like that. If you wanted to, you could factor a dz dx out, which would leave a 1 here, and a 2z here. You could do that. That's fine. All right. Now we have some actual equations. We have 3y cubed plus x squared is equal to y. And we want to find dy dx. So, what's the derivative of 3y cubed? Using the power rule, it is 9y squared. And that, I just took the derivative of something with a y in it. So dy dx pops out. Plus, what's the derivative of x squared? 2x. That's something with an x in it, so that's good. And what's the derivative of 5? It's 0. You've done the calculus part here, but there's a little bit of algebra left to do. We want to get these things, if it's possible to do so, and it usually is, we want to solve for dy dx. So remember when you took algebra, I'm going to subtract that to the other side, and then divide by that. So there is our derivative. So notice here, what's the difference between this derivative and derivatives that we've been finding back in Chapter 3? Well, I guess maybe there's different things you could say, but what I'm thinking here is the most glaring difference is that this derivative has a y on the right-hand side. Every single derivative that you took in Chapter 3 was all x's over here, and this one has a y over here also. So that's typical in this kind of implicit differentiation problem. All right, 11. How about this? All right, be careful. Watch out for when you need to use different rules. This is a product, x squared times y, so I need to use the product rule on that. Product rule is derivative of the first times the second plus the first times the derivative of the second. That's product rule applied to that. Plus, here, got the derivative of the first times the second plus the first times the derivative of the second. And every time I take the derivative of something with a y in it, like when I took the derivative of that y, it's dy dx. When I took the derivative of y squared, it's 2y dy dx. Equals, on the other side, what's the derivative of x? It's just 1 plus the derivative of y is dy dx. Okay, so are we done? Well, no, now is that algebra part. So how do you deal with this? Well, you want to get every term that has a dy dx onto one side of your equation, and then every term that doesn't have a dy dx onto the other side. And it should be, I think probably you understand why we're going to do that, but I'll tell you in a second, just in case you're a little fuzzy on what's going on here, why we would do this. I'm going to consolidate those twos. 2 times 2 is 4. Did you know that? I bet you did. And then this dy dx that's on the right side here, I'm going to subtract over to the left side. Okay, and then everything that doesn't have a dy dx in it, like this 1, I'm either going to leave on the right side or I'm going to move over to the right side. So this needs to get moved over to the other side. I'm just doing algebra here, right? And then I'm going to subtract this also to the other side. Okay, and then out of this, I'm going to factor the dy dx, which leaves behind x squared plus 4xy minus 1 equal to 1 minus 2xy minus 2y squared. And now we're ready to write our answer. I'm going to squeeze it down here at the bottom. So So dy dx, and I'm just going to divide both sides by that, is 1 minus 2xy minus 2y squared over x squared plus 4xy minus 1. There it is, the derivative. And again, notice that it's got x's and y's in the derivative here. Just a quick comment about this. There are some problems eventually that you're going to see that will ask you about finding horizontal and vertical tangent lines. Well, this is the slope, so if you want a horizontal tangent line, that's a horizontal tangent line is a tangent line with a slope of 0. So you would set this equal to 0. And I don't know if you've ever noticed this before, but the only way you can get a fraction to equal to 0 is if the top is 0. So you don't have to, this has nothing to do with the instructions for this problem. I'm just making a general comment about some problems that you're going to see. So if you want to find a horizontal tangent line, then that's where the top is equal to 0. And then if you want to find a vertical tangent line, that's a line with an undefined slope. Well, things are undefined when the bottom's equal to 0. So vertical tangent line is going to happen when the bottom is 0. That's just a comment about that. Because of this factoring thing and the way we get dy dx's in some terms and not other ones, this is a very typical kind of implicit differentiation result, this sort of fraction with x's and y's in it. All right. I think I just need to move on to a fresh piece here. See if we can get the rest of this onto one page. 13, we've got x squared y plus y to the 4th minus 3x is equal to 8. There's one product in here. Always a good idea to kind of survey the problem, kind of take a look before you jump in and start doing calculus so you kind of know what to expect. So I have one product here. That's just y to the 4th. There's a dy dx going to pop out there, and all good. Okay, so my product rule here, the derivative of the first times the second plus the first times the derivative of the second. That's product rule done on that. Plus the derivative of y to the 4th is 4y to the 3rd times dy dx. Derivative of minus 3x is minus 3, and the derivative of 8 is 0. All right, so same game as the last one. I'm going to try doing 2 algebra moves in one step here. I hope that's okay for you. I'm going to move this and this to the other side. And then I'm going to factor the dy dx off of the terms that are left on the left side. That's not too much, is it? Oh dear, that's a weird way of... Sorry, I was kind of anticipating writing the final answer here. And then if you really wanted to shortcut this, right, that's my next line here. You could have just put that under there. Maybe that's too many steps for us to skip, though. I'm not going to do that. So there's our dy dx. All right. Get the hang of it? 15, we got x to the 4th plus z to the 4th equals 1. And if you're like, oh no, that's a z, I don't know what to do, it's not a y. Nothing is different. It's just that when you take the derivative of something with a z in it, you get a dz dx that pops out instead of a dy dx. That's all. What's the derivative of x to the 4th? Oh, just my quick survey of this. There's no product rule or anything. This one looks like it's actually going to be pretty easy. So 4x cubed, and then 4z cubed dz dx equals 0. So dz dx, if I subtracted that over to the other side, it would be minus 4x cubed, and then divided by that. And then the 4's cancel. All right. We're getting there. 17 y to the negative 3 halves plus x to the 3 halves is equal to 1. So that's minus 3 halves y to the, when you subtract 1 from this, it goes down to minus 5 halves plus 3 halves x to the 1 half. Oh dear, I forgot the dy dx. I took the derivative of something with a y in it, and so I can slip it right in there. That's the easy mistake to make, right? You just get in the mode of all the rules that we learned in Chapter 3, and you forget about that dy dx, so be careful. Don't do what I did. So let's see. I think so that I can keep as many positive signs as possible, I think I'm going to add this over to the other side. So that would look like positive 3 halves y to the minus 5 halves dy dx equal to 3 halves x to the 1 half. And I just moved that to the other side. And of course, which side you write on which side doesn't matter, because they're equal to each other. And then I'll divide by that. So the 3 halves are going to cancel out. And I'll get this over this. I'm totally fine with you leaving it like that. If you're like, wait a minute, doesn't a negative exponent mean it's like flipped from, like that would flip it from the bottom to the top? You're right. It does mean that, so you could write the answer like that. But I'm okay with it like that. All right, 19. Looks like s is our variable here. You know, they've got a square root sign here. I'm going to rewrite that because it's more calculus friendly if I write it like that. And likewise with the 1 over x, 1 over s, that's more calculus friendly if you write it like this. All right, so now we can take the derivative. Derivative of anything to the 1 half is 1 half times that anything to the negative 1 half. And then times the derivative of what's inside. Well, the derivative of x is just 1, and the derivative of s is ds dx. And then here, negative x to the negative 2 is the derivative of that. And this is minus s to the minus 2, but s is not the right variable, so a ds dx pops out. Now, well, there's some algebra to do here, isn't there? Because I want to get the ds dx by itself, and the problem here is I can't just subtract or add this because it's being multiplied by this. So I need to do a little bit of algebra here. Let's decide how we want to deal with this. I think what we need to do is distribute this. We're going to get a very messy looking answer, and I'm not going to simplify it because we don't really care about that. We just want to get the calculus right. But we do have to do all this algebra work because part of the game here is getting the ds dx by itself on one side. Okay, so what did I do there? I distributed that. So this times 1, and then this times ds dx. Okay. Now I've got 2 terms that have the ds dx in them. So it looks like this one's negative, so I'm going to add that one over to this side. So I have 1 half times x plus s to the negative 1/2 ds dx, and then plus s to the negative 2 ds dx. And then on the other side, I have my minus x to the minus 2, and then I'm going to subtract this other thing that does not have a ds dx in it, minus 1/2 x plus s to the negative 1/2. I just subtracted that to the other side. Okay, now I've got my ds dx that I can factor out, leaving 1/2 x plus s to the negative 1/2 plus s to the negative 2. And on the other side, all this junk, pretty junky looking answer, huh? Okay, these are s's, not 5's. Careful. And then last step is to divide by this. So that's a lot of algebra work, but it's not so much, I think, that it's hard to do that. It's just maybe it's hard to do it without making any mistakes because of all those detailed steps. So there you go. That's a version of the answer. Could it be simplified? Yeah, probably some, because there's negative exponents in here, which is not preferred, and then there's a fraction in front of those. But this is totally fine. I don't think we want to take it any further than that. All right, a couple more. 21. This looks a little easier on first sight. We'll see. Maybe not, because this, before I start thinking about what rules, what calculus moves I'm going to be required to do here, this is a quotient. So I am going to have to do the quotient rule. So if you're watching this video and you're like, "Ooh, I didn't do that," then you should pause it right now and go back and try it again with the quotient rule. Not optional. You got to use the quotient rule when there's a quotient. So the derivative of y is just dy dx plus, here, quotient rule. Low, d high, the derivative of x is just 1, minus high, d low, over low squared. And then that's equal to the derivative of 1 is 0. I'll tell you what, that's another common mistake that I see in these problems with intro calc students, is forgetting to make the derivative of the constant that often shows up on the right-hand side in these types of problems, forgetting to make that 0 and just like recopying the 1 there. So watch out for that. Okay, what do we do with this? I've got to try to do some algebra to get the dy dx all by itself. So there's a couple ways that you can manage the algebra here. You could like move this to the other side by subtracting it and then like cross multiply. That's one way. Or you could think about like multiplying this entire equation through by y squared to get rid of that on the bottom. I'm going to go that route. It gets you to the same place, so if you did some algebra and you feel okay about what you did, then well, then that's okay, isn't it? So y squared times that, plus when I multiply y squared times this, it just cancels out that denominator. And when I multiply y squared times 0, it's still 0. Okay, now I've got 3 terms. 2 of them have dy dx's and 1 of them doesn't. So I think I'm going to have the least number of negative signs if I move these 2 things to the other side and leave the plus y there. It doesn't matter. You could move the y to the other side. It really doesn't make any difference. Your answer might look different, but just because of negative signs. And we'll talk about that in just a sec. So I'm going to leave the y here, and then I'm going to move this, add that to the other side, and subtract this. All right, now because I want my dy dx eventually to be on the left-hand side, I'm going to factor this out. I'm just going to write this stuff that's on this side. I'm going to recopy it over on this side because it's an equal sign and it doesn't matter which side you write things on. So that's equal to y. So what did I do there? I factored the dy dx out, which leaves behind the x minus y squared, and I just wrote that part on this side equals y. And then last move, dy dx is equal to y over x minus y squared. Now, if you move things around different from what I did there, it's entirely possible that your answer could look like this, which is also correct, because that's the same as this, just multiplying the top and the bottom by -1, which flips the sign of everything, and those are equivalent. So totally fine, 100%. Thumbs up. So is this. It's important that you recognize that you can look at those two and see that they're the same thing. That's definitely important. All right, number 23. This is the last one. All right. What's the derivative of the sine of whatever? Well, sine of whatever, the derivative is cosine of whatever, times the derivative of what's inside, using the chain rule here. The derivative of x plus y is 1 plus dy dx. All right. This side, the derivative of x is 1, and the derivative of cosine y is minus sine of y times dy dx. Took the derivative of something with a y in it, so pop, there it is. We got to do a little bit of algebra similar to what we did in number 19 here, although I think it's a little easier here. I got to distribute this before I can start moving things around. So cosine of x plus y times 1 plus cosine of x plus y times dy dx. And then just going to make that minus. Okay, so same game now. I want to move the things with dy dx to one side. And then this is good over here. I'm going to subtract that. And last couple steps, I guess. Factor out the dy dx. If you're super confident with your algebra management here, I am 100% okay with you like shortcutting one or maybe two of these steps. I tend to do that. I'm trying not to do it here, so that make sure you understand every move. But this algebra is pretty routine. Just depends on your comfort level, whether you need to write all the steps out or not. You got to do what you got to do. And dividing this over to the other side. And there it is. That's the answer. Want to look for a horizontal tangent line? Well, then you'd have to make this equal to 0. Want to know where there's a vertical tangent line? Then you'd make that equal to 0. But we don't need to do that in this problem. Okay.